Mm-mm. Okay, so definition 3 is on the board. It's all about end behavior of a graph. This is definition 3 because it picks up right where yesterday's notes left off at the definition 2. So just start right where you stopped yesterday. The end behavior is the behavior as x values approach positive and negative infinity. The symbol for infinity is like an 8 laying on its side. So basically what we're going to do today is we're going to look at a graph and see what happens when you plug in really, 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 really large numbers and really, 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 really small numbers and see how the graph behaves. So we are going to look at a couple different types of graphs and kind of investigate their end behavior and then see if we can make a broad overall generalization about end behavior depending on a couple characteristics of the graph. So the first linear graph you see on the left is y equals x, or y equals x to the first power. So the hardest part of today's lesson is the notation, I think. This is saying f of x approaches infinity as x approaches infinity. So basically this is saying as your x values get bigger, your graph also gets bigger. Down here this says f of x approaches negative infinity as x approaches negative infinity. So this is kind of where you look on your graph, and then this is what the graph is doing. So as we're going farther and farther into the negative numbers, you can see the graph is getting more and more negative. The graph to the right is that same linear graph, except now the lead coefficient is negative. So now f approaches infinity as x approaches negative infinity. So as you're going farther, farther, farther to the left, negative infinity, you can see that your graph is actually getting higher now. And down here, f of x approaches negative infinity as x approaches positive infinity. So as your x values are getting bigger and bigger and bigger, your graph is getting smaller and smaller and smaller and smaller. Okay, here are some quadratics. We spent all last chapter graphing these, so hopefully you have some idea about what happens to their ends. So this is saying f of x approaches infinity as x approaches negative infinity, and f of x approaches infinity as x approaches infinity. So what this is saying is as your numbers get really, 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 really big on the x-axis, your graph is getting really, 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 really high. As you go to the left, really, really, really big negative numbers, your graph is still going to be really big. Okay, so it's approaching infinity. Whether you're going to the right or to the left, your parabola keeps going up. And that happens when when y equals x squared. So you can see the one on the left is the equation y equals x squared. We know that that's a parabola opening up, so your end behavior in both the positive and the negative direction will approach infinity because it keeps getting bigger and bigger and bigger. Over here, now our lead coefficient is negative, so you can see that it's going down. So when your x values are approaching negative infinity, your function is approaching negative infinity. And when your x values are approaching positive infinity, when you're getting really, really big to the right, your graph is still going down. Okay? Any questions on what you've just seen? Now, the cool thing is the end behavior for any graph with an odd exponent as its leader, the lead coefficient, the degree is odd, it will behave like the linear graph for its end behavior. If the exponent is even, the end behavior will be the same as a parabola. So if you guys can remember the end behavior of a linear graph and a parabola, that will help you remember all the other types as well.